Welcome to Surds Level 4, one step in a level-by-level practice course. Pause the video now, try the problems on the screen, and I'll go through them with you shortly. At the end of the video, you can use the end screen to either practice more at this level or move up to the next one, and you can find topic-by-topic playlists on the channel homepage. In problem 1, we're simplifying the square root of 72 divided by 12. So to start, what we'd like to do is see if we can simplify the surd on the numerator. Now to simplify a surd, we need to find two numbers that multiply to make 72 in this case, where 1 is on our list of square numbers. And 72 can be written as 9 times 8, and 9 is a square number. Now it can also be written as 36 times 2, and in these cases we always want to take the largest number that we can. So we're going to use 36 here. So the square root of 72 can be written as the square root of 36 times the square root of 2. Because 36 times 2 is 72. Now the square root of 36 is 6 because 36 is a square number. So this gives us 6 root 2. And this means that our fraction becomes 6 root 2 divided by 12. And looking at the numerator and the denominator, the 6 and the 12 can both be divided by 6. So if we divide top and bottom of this fraction by 6, we have 6 divided by 6, which is 1, so we have 1 root 2 or just root 2, and 12 divided by 6 is 2. So root 2 over 2 is our final answer to problem 1. In problem 2, we're asked to simplify the square root of 32 divided by the square root of 18. Again here, what we'd like to do is simplify each surd individually if we can, and then simplify the fraction. So starting with the square root of 32, we're looking for two numbers that multiply to make 32, where 1 is a square number. And 4 times 8 gives us 32, but 16 times 2 also gives us 32. So we're going to use the largest one, which is 16. So the square root of 32 can be rewritten as the square root of 16 times the square root of 2. And because the square root of 16 is 4, this becomes 4 root 2. Moving on to the square root of 18. 18 can be written as 9 times 2, where 9 is a square number. So the square root of 18 can be written as the square root of 9 times the square root of 2. And the square root of 9 is 3, so this becomes 3 root 2. So our original fraction, root 32 over root 18, becomes 4 root 2, because root 32 can be written as 4 root 2, divided by 3 root 2, which is equivalent to root 18. We can see that we have a root 2 on the top and bottom of this fraction, so we can cancel those out, and we're just left with 4 over 3. And since 4 and 3 have no common factors greater than 1, this can't be simplified, and 4 over 3 is our final answer to problem 2. In problem 3, we're rationalising and simplifying 6 over the square root of 5. Now to rationalise means to remove the surd from the denominator. And we can remove the square root of 5 from our denominator by multiplying it by itself, because whenever you multiply a surd by itself, the square root part disappears. Now if we multiply the denominator by root 5, we have to do the same to the numerator to keep our fraction equivalent. So looking at the numerator, we can multiply 6 and root 5 together, and this gives us 6 root 5. On our denominator, we multiply root 5 and root 5 together, and this just gives us 5. Now because 6 and 5 have no common factors greater than 1, this can't be simplified anymore, and 6 root 5 over 5 is our final answer to problem 3. In problem 4, we're rationalising and simplifying 21 over 8 root 7. Now again here, what we'd like to do is remove the surd from the denominator, which is what rationalising means. And we can do this by multiplying the denominator by the square root of 7. And if we do this, we need to also multiply the numerator by the square root of 7 to keep these fractions equivalent. Now on our numerator, 21 multiplied by the square root of 7 just gives us 21 root 7. In our denominator, we have 8 multiplied by, and then root 7 multiplied by root 7 just gives us 7, again with those square root parts cancelling out. Now in the denominator, 8 times 7 is 56. So we have 21 root 7 divided by 56. And we now need to decide whether 21 and 56 have any common factors so that we can simplify this further. And they do. 21 and 56 can both be divided by 7. So we can divide the top and bottom of this fraction by 7. 21 divided by 7 is 3, so this gives us 3 root 7, and 56 divided by 7 gives us 8. Now 3 and 8 have no common factors greater than 1, so this is simplified. And this means that 3 root 7 over 8 is our final answer to problem 4. In problem 5, we're rationalising and simplifying 3 root 12 plus root 75 over the square root of 6. Now we could rationalise immediately here by multiplying the top and bottom by the square root of 6, as we have done in previous examples, or we could first try and simplify the surds individually and then rationalise if we need to afterwards. So I'm going to do it that way. I'm going to start with the square root of 12, which can be rewritten as the square root of 4 times the square root of 3, because 4 times 3 is 12, and importantly 4 is a square number. Now the square root of 4 is 2, so this becomes 2 root 3. Now moving on to the square root of 75, we want two numbers that multiply to make 75, where one is a square number. And 75 can be written as 25 times 3. So this is the same as the square root of 25 times the square root of 3. And the square root of 25 is 5. So this becomes 5 root 3. If we look at the square root of 6, there are no two numbers that multiply to make 6, where 1 is on our list of square numbers, so we can't simplify this at the moment. So going back to our fraction, we have 3 root 12, which now becomes 3 multiplied by 2 root 3, plus the square root of 75, which becomes 5 root 3. This is all divided by the square root of 6. Now we can continue to simplify the numerator, because 3 times 2 root 3 is 6 root 3. So we have 6 root 3 plus 5 root 3 all over the square root of 6. And we can still continue simplifying the numerator, because 6 root 3 plus 5 root 3 gives us 11 root 3. So we have 11 root 3 divided by root 6. Now we've simplified the numerator as much as possible, but we still need to rationalise, because we still have a square root on our denominator. And we can do this by multiplying the denominator by itself, so multiplying it by root 6, and keeping the fraction equivalent by multiplying the numerator by root 6. Now looking at the numerator, we have 11, and then root 3 times root 6 gives us root 18, because 6 times 3 is 18. And on our denominator, the square root of 6 multiplied by itself just gives us 6. Now we can continue to simplify, because 18 can be rewritten as 9 times 2, and 9 is a square number. So this becomes 11 times the square root of 9 times the square root of 2, all divided by 6. Now the square root of 9 is 3, so this becomes 11 times 3 root 2 divided by 6, and 11 times 3 root 2 is 33 root 2. So we have 33 root 2 over 6. Finally, 33 and 6 can both be divided by 3. So if we divide the top and bottom of this fraction by 3, 33 divided by 3 is 11, so we have 11 root 2, and 6 divided by 3 is 2. And we can't simplify this any further. So this means that 11 root 2 over 2 is our final answer to problem 5.